Hello, everyone. It's nice to have you again. As you know, I'm Rita. At least if you've been in part of our live streams before. But before anything else, we're super excited to have you here, and we're extra excited because we're kicking off our live streams after the summer break. And first of all, we hope you had a nice summer break or summertime vacations, and all included, or even if you're joining them soon. But first of all, let's start by welcoming you once again. If you're new here, we're super happy to see you here, and we hope to keep seeing you in future events. And if you've been in some of our live streams before, it's great to see you again. I think some of you must know what X6 is, but if you're one of the people that don't know who we are, actually, I can give you a brief overview of that. So X6 is an engineering company focused on providing capacity to product companies. We're not a typical project company due to several reasons, and that could be just a live stream itself, but let's keep it to other ventures. But we have a huge focus on community, a strong engineer culture as well, and a product drive. X6 represents the balance between projects and products, and our teams across Portugal work in building products while dealing with the broad stack. So if you want to know more about what we do, who we are, our team, open positions, our content, and so on, you can feel free to follow us on Twitter, on LinkedIn, Instagram, Medium. We do some cool stuff there, at least we think so. If you want to check that out, you can go ahead and do it. Today, as I told you, it's not only a special day because it's live stream day and we're live here on YouTube, but also because we have Bruno Baptista as our speaker. So Bruno is a principal engineer at Talkdesk with over 14 years of experience as an enterprise level engineer. Bruno has led QA and development teams, garnered skills in requirement analysis and development processes, and during his path, he has contributed to open source projects, and he also continues to help organize the Coimbra Java Users Group and the JNation conference, in which we are all present as well. Bruno's talk is focused on microservices. So in this presentation, Bruno will show you some observability best practices around logging, request tracing, and metrics. We'll also explain some tools and frameworks, how to configure and use them to monitor your services. But let's get into business and give the stage and the mic to Bruno. And go ahead, Bruno. It's great to have you here, and thank you for joining us. I'll give you the space, and also the stage, so you can go ahead and start your presentation. Thank you.
Hi, everyone, and thanks, Rita, for the opportunity, and also to XGeeks. So let's go to the presentation. Let me share my screen. Okay, and here we are. So look at these microservices. Oh. So this presentation, so Rita has already mentioned everything about me. So I'm a principal engineer at Talkdesk, and I'm part also of the Eclipse Foundation, Coimbra Java, and the JNation conference. And today we are going to talk about Carcass, microservices in general, observability best practices, and then we can see a demo on how to use all these together. So these microservices that I'm going to show you are implemented with Carcass, the Red Hat framework that was released about 2.5 years ago. So it was released under the label Supersonic Subatomic Java because used in conjunction with GraalVM to build the code, you can actually build the service into native code, getting fast startup times and low memory footprint. You can program in here using the imperative and reactive paradigms, using Java or other languages like Kotlin, for example. And it's developer friendly because it has a few features that were developed to improve the development experience, like live reloading of code and some other ones. So it's full stack, so you can use the Java EE most popular frameworks like JAX-RS, CDI, JPA, JTA, and also the Microprofile, microservice-oriented specs. It has a bunch of integrations with other tools, and we can say, well, it's not really new because the code that it uses most of the time, actually the code that you use to create your applications is mainly based on standard Java APIs, like the ones I mentioned before. But the way everything is glued together gives you a much better experience, easy to configure, and startup times. That's the great difference with the past. So that's mainly the reasons, and also the community. The community, you can go to the website. You can the code is open source, so you can contribute to it. The documentation is quite up to date and very helpful in my experience. So Microprofile. So to create microservices, this is on the Java enterprise world, apart from Spring, this is a must-have. So Microprofile is CDI based and used in conjunction with JAX-RS and JSON binding. You can have a standard way to configure services. You have an API to create your own health checks, to integrate with open tracing, to secure your web services with your services with JSON Web Tokens, the JWT tokens. So you can document the endpoints with OpenAPI, use REST clients for server-side inter-service calls using REST, and also fault tolerance features. Those are the ones on my experience that are mostly used. So other cool stuff. It's easy to integrate with containers. So like Docker, you can build a jar with all the artifacts and create easily your Docker images. The library that I mentioned before when you are developing, and it includes some other things like cores, integration with Flyway, so you can update your database schemas much more easily and in an automated way. And well, as I mentioned, the extensions for other tools and the documentation. So the performance, I told you that it starts faster, but it's not just with the native image and the native code that are much faster. It's also when used in JVM mode. So this is a sample application here that you can see. From experience and comparing with a full Java EE container, for example, it's much faster starting. We can see probably near the order of magnitude on starting with JVM mode. With native code, the startup time is much faster because of the native code, and the memory footprint will also decrease. However, the number of requests will be slower. That's why for server deployments that are always on, I tend to prefer to use the JVM mode, because the just-in-time optimizations that the JVM is able to perform will give you a better throughput and better latency as well. So those just-in-time optimizations are kind of guessed when you compile the code, but they are not active when the server is running. So it will not improve that much. So we use this framework to create our services. And what's really a microservice? Is it a really tiny service? How tiny it needs to be? So because size in microservices has always been kind of a point, but according to the microservice.io definition, a microservice is something that is highly maintainable and testable, that it's loosely coupled. So the service doesn't depend strongly on other services, and usually it cannot share database with other services. So it has to be highly independent. Also, this allows you to independently deploy the service. So you don't need anything else apart from the needs of that microservice to deploy it. And this also makes it easier to be owned by a small team. So if you contain the business domain of the service, it will be possible to deploy a microservice with a small Scrum team. And nowadays, with the way enterprises companies are organized, you will tend to see many Scrum teams sizing from 6 to 9 elements that have capabilities in multiple disciplines like backend, frontend, QA, and sometimes DevOps. And those persons are able to actually deliver the service in an independent way. So this kind of limits the amount of code that you are able to put on a service. Only if those persons are very efficient and work really fast, you will be able to bloat out of proportion the scope of that service. Also, when you talk about microservices, so this is what you get when you search images of microservices on Google. It's a total mess. It's super complicated, and there's more into it than what we mentioned before. So because you will have many services, you also need to focus on automated deployment, intelligence in the endpoints, and you also need a decentralized and automated way of controlling your microservices. And because you cannot control what you cannot see, there comes observability. So observe something. Observability, it's a strange word to say, and there's a classical definition for it. It's on Wikipedia, you can search for it, and they define it as a measure of how well internal states of a system can be inferred from the knowledge of the external outputs. The observability is actually tightly coupled with controllability. So how you see it allows you to control it. And this is the central focus of a more suitable definition for the microservices wall, which would be the capability to allow a human to ask and answer questions. So, and for this, we have 4 different vectors that are very important. So logging, tracing, metrics, and alerting. So for logging, all Java services since ever have logging. But with microservices, you need much more than the standard logging of the output. You connect to a machine, you see the log file in there. With microservices, that's something that you cannot do. For starters, the services, most of them run on Docker, and you don't really know which system capabilities are inside Docker. So you cannot count, you can log in and see the log there. So most companies, what they do is they collect the logs of all the services and they centralize it on a central point. Like they have Elk stacks running the logs. Like Elk is Elasticsearch, Logstash, and Kibana. And there's also other types of centralization now with OpenTelemetry. And much more important, for the logging, because you are getting logs from all these different services, multiple instances of the same service as well, it's that you need to add some context to each line that you log. It's not just, okay, I did this, I did that, but okay, you did this and that. It's not enough the thread. You need to also add the machine that issued this. Sometimes the data center that where this was deployed, if you are a multi-data center company, and also some companies or some services run on canary deployments with blue-green deployments. So even for a service, there are sometimes different versions of the code running at the same time. So you need to understand for each logging line at least what was running at the time. So you need to add a lot of context to each log line. Usually information about who is doing the request and open tracing context, so you can follow the request everywhere, is also very useful. So JSON format helps you also to get complex queries if you are using Elk on Kibana, so you can find faster what you are looking for. If you just have plain text everywhere, it's going to be very hard to get the right information. Also, proper log levels need to be enforced across the organization. So error, if the execution of some part was aborted, like a request had to be terminated because some condition gave an exception, or some job couldn't end, so that's an error. If something went wrong but the execution could continue, that should be labeled as warning. So everything else to validate the proper execution should be info. Everything else should not really be on the logs by default. So debugging and tracing and all that should be activated on per class as needed basis. Because if you log too much, it will be harder to actually find useful things when you need them. Also very important to log is transitions between different microservices. And also, if you are running a job, it's useful to get all the job steps, and when it ends, verified, so you can actually understand if that job has ended and what was the result. So these are some useful guidelines about logging. Then there is distributed tracing. So, and for distributed tracing, we use open tracing, and you can also start to use OpenTelemetry, which is a newer standard that is going to replace open tracing. And the distributed requests can be followed. So imagine some user does a request to service A, then service A needs to call service B, and then service C, and so on. And with distributed tracing, you can follow all these calls between services, and you can measure how long they took, if they were successful or not. So this will allow you to pinpoint which service is giving the error, if an error happens, and to pinpoint which service is giving you the performance bottlenecks. You can also do all this with logging, but because the logs, you will need to correlate logs of different services, this will be very hard. Because sometimes the logging system is indexed by service, so it's it's possible, but it's hard to actually get an index that spans multiple services. Also, you need to have metrics, and for this you have many ways. So Microprofile metrics, micrometer, OpenTelemetry also provides you ways to generate metrics. And you can also use some closed source application performance managers like New Relic. Nowadays, Quarkus is very well integrated with Micrometer. It's also the framework that's mainly used in the Spring Boot world. And with this, you can very easily retrieve the JVM metrics. So how many threads are you using? What's the heap size? When is the garbage collector running? Those kinds of things. But also important metrics about the request metrics. So how long is taking your requests, and if your service is down for some time, or if you are having too much errors. So this will give you the basis to create your own SLA, service level agreements. And with all these, you can create alarms and make yourself less bugged and less intrigued. So if you create proper alarms, you will not find that your service is down by surprise by the call of some customer. You can be actually proactive, and you can detect and notify those errors. You need to monitor the metrics and the logs sometimes and tweak to generate those alarms. It's not just the errors that are thrown, like for example, 500 errors should be labeled as bugs. So at some point you want to know that they are happening, so you can issue bugs, so you can correct them. And you have also many tools available to generate these alarms. So standard application performance managers like New Relic, but there's also some open source tools, most notably Alert Manager from Grafana. And so let's shift to the demo, where we will see all these working together. So I have two services here. So one Legume service that uses a database and communicates with the second service through RabbitMQ. And the second service transforms these legumes into superheroes and stores those superheroes in its own database. So let's check the code. Okay. So I don't know if there are any questions right now. Rita? Or everything is okay?
Hi there, Bruno. So we don't have any questions yet, but it's great that you just mentioned that. So if you have any questions for Bruno, I bet you're being super clear. That's why you don't have yet questions. But if you have any questions for Bruno, you can go ahead and leave them in the chat. That will make our discussion even better. So feel free to do that, and we'll ask them to Bruno, and Bruno will get back to us with that. So if you want to move forward, go ahead.
Okay, so let's look at the code. So share screen again, and let's go. So here I have IntelliJ, and I have the couple of services that I mentioned before, the Legume service and the Superhero service. And in here, so let me show you how this is built. So this is a multi-module Maven project with these two, and almost everything is defined at the parent POM level. So on dependency management, we use the Quarkus BOM to define the Quarkus version that I use here, which is a bit outdated. Quarkus is now on the 2 series, the 2X series. And I use Camel to actually send the messages and receive messages from RabbitMQ. And for this, I use the Camel Quarkus integration that is available. So I'm using JSON binding, some fault tolerance, because fault tolerance is very important for microservices. I can tell you why in a moment. and persistence with Postgres. So I'm using a Postgres database to persist all the legumes and the superheroes. I'm documenting by REST endpoints with OpenAPI, and I'm using Hibernate Validator to validate the entries that I get. So if I go here, so let me check if I have something interesting here as well. Oh, Lombok. I'm creating many entities with Lombok. I will explain what Lombok is next if you don't know it. And also I'm using open tracing here. So the rest are plugins, and so the Carcass Maven plugin that allows us to live code if needed. So on the source code side, so this is a plain Maven project. So you have the main and the tests. Let's go through the code here. So the health checks. So there are two basic health checks. So the liveness that we use here using the Microprofile health liveness. So Microprofile defines this annotation and this interface that you need to implement. So you define your own liveness. So in here, I'm just returning that the service is up, and I have configured here some property that I can tweak, and I'm returning that property every time the liveness check is used. So on container managers like Kubernetes, you need to have these liveness and readiness probes active, because Kubernetes will first check your liveness to see if the service is already up. When this endpoint returns, this will expose a REST endpoint on on health/live. And when it gets a response, it assumes, okay, the service is up, everything has started. And then it checks the readiness probe. And only after checking the readiness probe, it starts to divert load to it. So the HTTP request will start to be redirected to that service once the readiness probe gives you an up, and it's okay. And for this readiness probe, we do an actual database query. So we inject here so we use the readiness annotation from Microprofile as well, and we implement the health check. And by injecting the entity manager from JPA, we can actually connect to the database and do a simple select one. So this will return always one, but this is what we want. We actually want to go to database, and the database will tell us one, and that's what we need here. Because this will allow us to test if the database credentials are okay, if the database is responsive, if our connection pool has available connections, all that. And if you get any exception of if the response is something else, which is very unlikely, but it will return that the service is down, both here and here. So this is for the Microprofile health check part. Also from Microprofile, we have the OpenAPI. So OpenAPI allow us to document all the endpoints. And in here, we are creating a legume endpoint where we can do a post that will init our service. Mind you that this is an interface, so I'm putting all these annotations on the interface. I will tell you why later. So that this method will actually provision the database with some seed data, or we can post a particular new legume, and it will add it to the database. Then we can delete and also list wherever we have in there with the get. So this is an interface that has all these annotations. As you can see, it's quite verbose. And this resource simply implements that interface and doesn't need to deal with any of that. And additionally, it's an application scoped CDI beam. And it gets much simpler because in here we can write all our logic right away. So we implement the provision method where we add some default legumes like a carrot and a zucchini, and we implement the add, the delete, and so on. Also, we use a microprofile fault tolerance feature here. So you see these two annotations. So this is a timeout annotations from Microprofile. So Microprofile fault tolerance and fallback. And they are implemented in Carcass with the small RAI fault tolerance libraries that are an implementation of Microprofile fault tolerance spec. And in here, I'm saying that there's 500 milliseconds timeout. So if the list takes more than 500 milliseconds to return, it will throw an exception, a timeout exception. But because we are using the fallback, any exception thrown here will call the fallback method, which is in here. And it will return something that we know it's a failed legume. So what else we have interesting here? So we have the entity that will store, the JPA entity that will store everything. And as you can see, we are just defining the attributes. We don't have any methods, getters, setters, whatever. So, and for that, we use the Lombok annotations. So these Lombok annotations will, on compile time, they will actually generate the code equivalent to data. So the data annotation will define that this will have getters, setters, and we will also add a no args constructor, a constructor with all the arguments, and the equals and dash code based on the ID, which is this attribute here. And we'll also add a builder. So we can create legumes following the builder pattern, which is super useful. And the same for the TTOs. So we are actually converting, we are not sending here the entities through the wire on the REST response. We are returning always DTOs that are plain POJOs. And so we have here the legume item. So this is a read-only with all the data. But if we want to create new legumes, we use the legume new DTO, which doesn't have the ID. So we cannot define the ID because it's generated by the server side. So whoever is using our API will know that if they want to create a new legume, they just need to send these two attributes. Everything else that might be returned on read is from the responsibility of the server to find it. So also configuration. We use Microfile configuration in here. It's the standard way to configure Carcass, and it uses like Spring Boot an application.properties file. And everything is in here. So this is the runtime application.properties file that will be used when we build this and we'll execute on runtime. All these properties can be overridden as environment properties. So if you have an environment property in uppercase with underscores replacing these dots and also this dash, if it matches this string here, but in uppercase, it will replace whatever it's in there in the environment variable with in here. Instead of Postgres SQL, it will use something else. And it's the same for all the other properties. And so we have here the Jaeger service configuration. So this is the open tracing configuration. So this is where we say, okay, this is the service has this name, and it will be shown on the tracing side. And this is how we are exposing. And so this is how we are formatting our logs. This log is not yet, so it's JSON based. The format uses this, but it's JSON based. So we have here some properties to actually convert the names of some fields, because I want to use this name instead of this, if this name happens to show up in the logs. But more on that later. So we also have tests here. So we have some integration tests. So this is actually the only Quarkus related annotation that we use in all the applications. It's the Quarkus test. So this allows us to start a container and run this test. And it will wire everything that we have configured here, but using the application.properties file from the test side. And for that, we are using an in-memory database, not a Postgres. So we are using here H2 to run the integration tests. So this example is quite close to some service that you would actually need to implement. So it has a real database, you have a different database for testing, you have documentation on the endpoints, you have liveness and readiness checks. You can implement business logic inside a Legume resource. So it's pretty much ready to work. So let's go and see this in a cluster. So I have the cluster defined on a Docker container, and the Docker container has all the services that I need to start for this. So I have a database, which is Postgres, so, and a RabbitMQ service, and the superheroes and the vegetable services, a Jaeger collector that is kind of a sidecar, uses a sidecar pattern. So it's attached to each service to collect the traces and store them on a Cassandra database. So it forwards it to Prometheus, that then stores them in a Cassandra database. And we have log aggregation that is performed, and it can be, we can see the logs not in an elk stash, but we are going to see them inside Grafana with the Loki plugin. So everything should be up, at least it's what it says here. So let's go here and let's go to localhost 3000, which should be Grafana. So I'm starting this. So let's start with admin. I'm going to define the same. And now we have Grafana. So here we have dashboards. We can explore. So let's check on Loki, the log browser. So if we go here, we have many things that we can actually check the logs. So there's logs for each one of these services. I'm going to check the vegetables service. So show the logs. And you can see here the logs of this particular service. So the time moves up. So this is the most recent one. And this is telling you which features are being installed on this particular instance of Quarkus. If you go here on the top, you'll see that you can see the Prometheus will give you the traces, but usually people are more familiar with Jaeger. So we can see this using kind of a Jaeger UI plugin for the traces. And we have traces here for vegetables and for superheroes. Let me do a recent call here. So, and in order to do this call, I can go here to the documentation, and I have several calls that I can perform. So let's go back to the liveness. Actually, I will not use a curl for the liveness. I will use a container here. So sorry, not this call, just this. So it says that it's up. So this port, so the other service should be on 81. Which should be the superheroes. It's also up. And if we want to see the readiness, we need ready. And it will say us that the database connection is up. So this one. Carcass has a built-in database check, but I tend to create my own because that connection check just checks if you have available connections. It doesn't actually verify that you can connect to the database and get a response from it. So I usually create a new one just for that. And so let's go and see. So let's initiate the database here. And for that, I need to do a post. So I will need a curl. So I created these. So remember that initialization code would create a carrot and a zucchini. So now if we go list the legumes in there. Oh, but not with the post. We'll have a list of zucchinis and carrots. But if you go to the other endpoint on the other service that receives everything using RabbitMQ messages, it should have a resource as well. And this resource is published under heroes. So let's list the heroes that we have there. So it's on a different port, 81. Okay, so now it has a super carrot here and a super zucchini. So let's see on Grafana how this is translated. So if we go here to the logs again, and we see the vegetables. So what do we have here? So the last log entry is message sent, zucchini. So we sent a message to the other service that was saying zucchini. And the last thing that we have on superheroes is that hero created zucchini Superman. And probably when we started that, so message received. So we can check this, which is easier. So we can just check the message, the payload that says message. So new message arrived, message received, it's zucchini, and then we created this one. But then it's much more interesting if we see it on Jaeger. And if we go to the vegetables and we check the provision, so posts, so we see that it happened right about now. So this is Portugal time, which is the same as London. And we see here that the vegetable service processed during this amount of time. It sent this message here. And this message, because the tracing context is propagated also through a RabbitMQ was received here, and the hero was added. And then I also add some tags here, but it doesn't add more details, sorry. But in here, you can also see that we sent the hero message and it was processed later on here at hero. One thing is pretty clear. So the first time that we send a message, it takes much more time than the second time. You see? And also, the first time we receive a message takes much longer than the second time that we receive them. This is explained because there's a lot of classes that need loading and a lot of context creation when these operations happen. And then after that, it's super fast. So, and that's why this reduces. And this kind of visibility can only be easily provided by open tracing. So this is providing you insight across multiple services. So you can also get metrics. Let me get you some metrics here. So each service produces an endpoint called metrics here. And if we execute this is actually what the metrics collector call as well. So they execute this and get all the metrics that is being accumulated in the background by Micrometer, because we are using Micrometer. So this is a bit hard to see, but if you use Grafana, you can create dashboards. You can manage dashboards, and you can even import dashboards. So, and you can go to, well, Grafana dashboard, I don't know, Carcass. And some results should show up here. So, and we landed on the dashboards that are available on the Grafana website. And each dashboard that you can use has a particular ID, in this case, this one, which is the same as here in the REST endpoint. And if you copy it and you use it here, it will actually load that dashboard with everything that is needed. Oh, I need Prometheus data with this, because I can have multiple sources. And now I have a dashboard explaining what is going on with this particular cluster. So I can see both services, so the vegetables and the superheroes, because the Prometheus has been collecting all those metrics in the background and storing them. And now I just need the dashboard to interpret the data that I already have stored in the database. So as mentioned before, so IO rate, so the amount of requests, you can check the heap memory, non-heap. Well, but this is just for this particular dashboard. You can create your own, or you can build graphic by graph the ones that you want. So this is essentially what I have to show you. Any questions?
Oops, I was mute, sorry. It seems like everyone is a bit shy, but 10 seconds for some questions for Bruno. Do you have them over there? This is a great timing for that. I think people are either writing or thinking or just taking notes of what you just showed us.
Yes. Okay. So
So Otavio says that it was pretty good, so it must mean that there are no questions.
So let me just share the last slide then.
Of course, go ahead.
So let me share again. So you will be able to. So this is where you find these slides here, and the code is open sourced and can be checked out here. That's why I didn't went into too much detail. Even for the service mesh, you'll be able to see the container files. And special thanks to Andrei Ilikas that did most of the work in the container files and setting up the infrastructure for all the services, Grafana and so on that we have seen. He has actually a pretty interesting presentation about service meshes that is kind of a second part for what I've shown you today. You can also check my, Twitter feed here, and that's pretty much it.
Awesome. Thank you so much, Bruno. And I think people will revisit for sure this talk of yours, which was quite interesting.
A bit blurred. Sorry.
You are a bit, yeah. Now I think
camera is.
No, it's fine. It's part of it. But I was just saying that if for all of you watching this, even if it's live or afterwards, feel free to leave your questions in the comments. We'll forward them to Bruno, and we'll get back to you on that. So thank you so much, Bruno. It was nice to have you here. It was nice to restart our live streams with you, and I think it was a great presentation for that. So thank you so much for availability. Feel free to join us again in the future if you'd like to. We're always happy to have you here, and thank you also for everyone that joined us. It was nice to have you here, and we hope to see you in the next ones as well. Thank you so much. Have a good rest of your evening. Bye, everyone.
Thanks very much, Rita, and to XCX as well. And also to a friend of mine, Tiago, that I didn't view for a very long time, and he left some comments here in the beginning.
He did? Oh, okay. That's cool. That's always nice. That's it's nice to have our live streams not only bringing old friends together. So that's good. Thank you, Bruno, and thank you, everyone. See you around. Bye.
Okay. Bye.